Today we're going to be working on 6.5 notes, which includes solving radical equations. Now we have two different types of radical equations that we're going to solve. We're going to solve when we have variables only in the radicand, that means inside the radical, and then we are going to have some that are inside and also outside. So this is really important to be able to see and to be able to do the different types of operations. So let's start off with the easier version, just variables inside of the radicand. So you can see right here we got a variable inside that's 2x's on the inside of our radical. So we're going to first isolate the radical. That means we need to add 2 to both sides, end up with 2 times the square root of 2x plus 2, which is now equal to 12. We will then divide both sides by 2 to get rid of the 2 out in front. And then from there we will have an isolated radical of root 2x plus 2 is equal to 6. Now we're going to need to get rid of our square root by raising both sides to that second power. We're going to need to square both sides. So we're going to end up with no root and no square on the left side, just a 2x plus 2 is equal to 36. Now we're going to solve for the rest of this, just normal algebra 1 stuff. So we have minus 2 from both sides. Get rid of the easy things first, order of operations. And we'll have 2x is equal to 34. So maybe I'll minus 2. There we go, and I'll drag this up. From here, we would need to divide by 2, and we will end up with x being 17. Our last step is to check our answer, and to do this, we just substitute it back into the original. So we're going to use this x equals 17 as the original, so let's try it. 2 times the square root of 2 times 17 plus 2 minus 2 on the outside is equal to 10. Let's try it. 2 times 17 is 34. 34 plus 2 is 36. The square root of 36 is 6. So this is now 2 times 6 minus 2 is equal to 10. And I think this is true because 2 times 6 is 12, and 12 minus 2 is 10. So that's definitely true. Let's try this next example here. We have 4 times the cube root of 13x minus 1 minus 5 on the outside is equal to negative 1. We're going to get the radical by itself by adding 5 to both sides. So now we have 4 times the cube root of 13x minus 1 is equal to 4. To get rid of the 4 in front of this root, we need to divide both sides by 4. That's gone. We now have the cube root of 13x minus 1 is equal to just 1. To get rid of a cube root, we need to raise both sides to the power of 3. And we're going to end up with 13x minus 1 is equal to 1, because 1 cubed is 1. Add 1 to both sides, and we end up here having 13x is equal to 2. Divide both sides by 13. Cancels out on the left side, and we have a fraction. Now this might feel like it's not the correct solution, so we should check it. And let's try it. We have the original equation of 4 times the cube root of 13 times 2/13, or 2 over 13, minus 1 minus 5 on the outside is equal to negative 1. Well, let's just do some quick math. 13 divided by 13 is 1. 2 minus 1 is 1. The cube root of 1 is 1, so this is 4 times 1 minus 5 is equal to negative 1. 4 times 1 is 4. 4 minus 5 is negative 1, and that's equal to itself. So this one works. Didn't seem like it would, but it does. It works out just fine. So now we're going to come to the second part, which is variables inside and outside of the radicand. We have one on the inside and one on the outside. So we're going to follow our steps. We're going to isolate the radical again. We're going to square, in this case, square both sides. We can't forget to distribute. And then we're going to solve our quadratic and then check all solutions. So I'm going to first start off by subtracting 3 from both sides, and I'm going to end up having the square root of 2x minus 7 will be equal to x minus 3. From here, to get rid of our square, square root, we need to square. If I square one side, I must square the other. On the left side, the square and the square root cancel out, inverse operations. And it'll be equal to, and I'm going to take this x minus 3 squared, and make sure to rewrite it and FOIL it. X times x, x squared. X times negative 3 is negative 3x. Negative 3 times x is another negative 3x, so that's negative 6x's. And then negative 3 times negative 3 is a 9. So don't forget to do that. That is what we would call that distribution step, or FOILing. You can also use the box method. Now, since this is a quadratic power of 2, we're going to have to set everything equal to 0. So I'm going to subtract 2x from both sides, and I'm going to add 7 to both sides, leaving me with 0 on the left side of the equation is equal to x squared minus 8x plus 16. Now, if you can't recognize it, you can use guess and check or the box and diamond, but for right now, I'm just going to say that this is going to be a perfect square trinomial, and it's going to be x minus 4 times another x minus 4, both equal to 0, which will give me the same solution of 4. So I'm going to check this just in case. That's what we're supposed to do. Replace the x's with 4's. And let's try it. 2 times 4 is 8. 8 minus 7, rooted is 1. So square root of 1 is 1, plus 3 equals 4. This is true. Works out. All right. At any point in time, you can always stop, pause this, go back and rewatch it. But we're going to do the last example here. And our last example is the square root of x plus 7 plus 5 on the outside is equal to x. So I'm going to start off by subtracting the 5, which gives us the square root of x plus 7 is equal to x minus 5. The only way to eliminate the square root is to square both sides, and we end up in the same conundrum from up above. The square and the square root cancel out. X plus 7 is left on the left side, and then we will we'll FOIL this out or distribute this out to be x squared minus 10x plus 25. Subtract an x from both sides and a 7 from both sides to get it set equal to 0. So now I have 0 equals x squared minus 11x plus 18. So this one's going to take a little bit more work, but the numbers that multiply to be 18 and add to be 11 are going to be 9 and 2, both of them being negative. And then we're going to set these equal to 0. So our first factor is 2, and our second factor is 9. And we should definitely check both of these. So I'm going to try the first one, 2. The square root of 2 plus 7 is 9, plus 5 should be equal to 2 because x is 2. And what I get here is 3 plus 5 is equal to 2, and that's not true. So x equals 2 is not a solution. I'm going to check the last one. If x is 9, then it's 9 plus 7 underneath the square root, which is 16. Square root of 16 plus 5 should be equal to 9. And I'm getting all this from the original equation, so if you need to see it, that's where I'm getting it from, using substitution. Square root of 16 is 4. 4 plus 5 is 9. And that's true. So x equals 9 is the solution that we want. So sometimes we'll have two solutions that work, sometimes we'll have one, and sometimes we'll have none. Just is what it is. If you have any more questions, please feel free to reach out and email me or talk to me in class. I hope you have a wonderful day.